Good morning, students. This is our second lecture on basic electrical systems. In the last lecture, we saw the basic concepts of electrical systems, and in this lecture, we are going to discuss further the important concepts regarding basic electrical systems. So, we are going to start this lecture now. Now, the first important term is the conductor. The materials with fewer than 4 electrons in their outermost orbit are called as conductors. Copper is an excellent conductor because it has only one electron in its outer orbit. This electron is far enough from the nucleus that the pull holding it in the orbit is relatively weak. As shown in the figure 9, a conductor is any element that has 1 to 3 electrons in its outermost orbit. Copper as a conductor. Copper is the conductor most commonly used in the vehicles because its price is reasonably compared to the other conductors with similar properties. As shown in the figure 10, how copper is excellent conductor of electricity has been showcased. Due to having just one electron in its outermost orbit, making it easy to be displaced and cause the electron flow, which is the definition of the electricity. Now, the most important question, is water a conductor? Pure water is an insulator. However, if it contains the impurities like salt or dirt, it becomes a conductive in nature. Because it is difficult to keep water completely pure, it is usually considered capable of conducting electricity, especially at high voltages, such as from household outlets of 110 volts or around 220 volts. Now let us discuss insulators. The proton and neutron in the nucleus are held together very tightly, and normally the nucleus does not change, while some other electrons are loosely held and can move from one atom to another. Some materials hold their electrons very tightly and making it difficult for electrons to move through them. These materials are called as insulators. Now, next important part, insulators. Insulators are materials with more than 4 electrons in their outermost orbit. Because they have more than 4 electrons, it becomes easier for this material to gain electrons rather than to release them. As shown in figure 11, insulators include elements with 5 to 8 electrons in their outermost orbit. Because the insulators do not permit the movement of the electrons from the outermost orbit. Therefore, the flow of electrons is not so much easy in case of these electrons. The examples of these insulators include plastic, wood, glass, rubber, ceramics, and varnishes to insulate the copper wires in the alternators and the starters. Now, the next important concept is the semiconductor material. The semiconductors are the materials with exactly 4 electrons in their outermost orbit. These materials are neither conductors nor insulators. Figure 12 shows that semiconductor elements contains exactly 4 electrons in their outermost orbit. Now, this is an important concept in which we get the idea of the electron flow in a particular materials. When an external power source, such as a battery, is connected to the ends of a conductor a positive charge, which indicates that there is a lack of electrons, is placed on one end, and a negative charge is placed on the opposite end. The negative charge repels free electrons from the atoms of conductor, while the positive charge attracts these electrons. This attraction and repulsion causes these electrons to flow through the conductor. Now, as you see, as depicted in figure 13, current electricity is the movement of electrons through a conductor. Now, the difference between the conventional theory versus the electron theory. Now, conventional theory states that current flows through a circuit from positive to negative, and in different textbooks it is also depicted in similar fashion. This theory is used in all automotive electrical diagrams and schematics. However, the discovery of the electrons and its negative charge led to the electron theory, which states that there is electron flow from this negative to positive. But for our sake of convenience, the theory which is depicted in the textbook of James Halderman or any other Indian author that we are going to follow. Therefore, we will consider the flow of electrons from positive, that is a high potential region, to negative, that is a low potential region.